The Future of Spatial Structures, a conversation with global leaders in the field. In our first podcast in this two-part series, we explored the history of spatial structures, which began to appear in the mid-20th century, when engineers such as Eduardo Torrojo and Fray Otto started to create lightweight shell structures based on geometric principles. But what will the future of spatial structures look like? Ahead of the 7th International Conference on Spatial Structures and the 61st Annual Symposium of the International Association of Shell and Spatial Structures, IASS, to be held at the University of Surrey in August 2020, we talked to some of the leading figures in the field about the technologies and developments that will shape the future of this fascinating discipline. With spatial structures a fairly specialised sector within civil engineering, it might be interesting first to find out from today's world leaders in spatial structures how their personal interest in the discipline began. For many, such as René Motro, Emeritus Professor at the University of Montpellier, a love of geometry was the chrysalis.
I could say that my personal interest was linked to my love for geometry. It was the beginning. But afterwards, I work at the interface between engineering and architecture, at the interface between form and forces, between visible and invisible. Geometry is visible, you can measure it, you can see it, you can take a picture. Forces, nobody saw forces in life. This is a, let's say, mental construction, but this is very important. And my personal interest is to establish a link between form and forces.
Haris Gontas, Professor at the Institute of Steel Structures, National Technical University of Athens, and Editor-in-Chief of the Journal of the International Association for Shell and Spatial Structures, tells of his own journey towards a career in spatial structures.
Well, it's I would say it's a very old story. My father was a structural engineer. He was not particularly involved with spatial structures, but I started loving structural engineering as a child, and then I did my undergraduate studies in Athens, my hometown, and my thesis advisor was I would say an early researcher of finite elements, which had started being developing at that time. So my first approach to spatial structures was from the computational point of view. Then I went to MIT for graduate studies and a PhD, and it so happened that my PhD topic was on deployable structures, which is one type of spatial structures. You can think of them like umbrellas, structures that open up and close, so when they are folded they take little space and they can be stored easily and transported easily, and then they open up and can be used. So that was a further step. And then when I went back to Greece and I started as a faculty member at NTUA, I got exposed more to sides of detailing, which are important, which is an important aspect of steel structures. And I would say that all this combined excited my interest into spatial structures.
For Jerry Park, Emeritus Professor of Structural Engineering at the University of Surrey, a particular event cemented his fascination with spatial structures while studying under Professor Szymon Murkowski, a pioneer of spatial structures such as Heathrow's first jumbo jet hangars.
I developed my interest really when I came to the University of Surrey a long time ago. My Professor Murkowski, was a world expert in space structures. And so I was doing my PhD research with him. And after I started doing research into space structures, there was a big collapse in America. So in Hartford, which is on the east coast of America, midway between Boston and New York, they built a coliseum. So it's like a sports stadium, which I think they seated about 110,000 seats. And they had a basketball match in there, and then everybody went home. And then during the night, they had a snowfall and the whole structure collapsed. So it's a major disaster, but nobody was killed. And following on from that, there was a lot of investigation as to why this happened. And I thought, this is interesting. The whole lot I was very interested in. Still am, actually. There's still...
Often taking the form of iconic sports stadia, museums and public spaces, spatial structures are a high-profile specialism within civil engineering. How would the field's leaders define the contribution of spatial structures to civil engineering as a whole, and what is their real importance? Carlos Lazaro, Associate Professor at the Universitat Politécnica de Valencia, has this to say.
I wouldn't say that spatial structures contribute to civil engineering or vice versa. So, because you could say that civil engineering contributes to spatial structures. The important thing of spatial structures is that unlike other structural types, they mix several disciplines, and structural mechanics, which is one of the specialties of civil engineering, is one of them, but they also mix geometry, and in that aspect architects are much more and better trained for mastering geometry than civil engineers, and at least in my country. And this is the reason why some of the key persons that I have mentioned were engineers, like civil engineers like Torroja, but some others were architects like Candela or Fray Otto, and some others like Mamoru Kawaguchi had a background in architecture and specialization in structural engineering. So it's really a field where you can find collaboration between architects and engineers.
Sigrid Adriansens, Associate Professor at the Department of Civil and Environmental Engineering at Princeton University, believes that spatial structures have the power not only to embody stunning design solutions for sports stadia and other large public buildings, but also to solve some of the key challenges we face today and will face tomorrow.
I think this area is very important because spatial structures can carry very heavy and extreme loads, and they can be used for novel applications. So especially at the beginning of the 21st century, I think they have great potential to carry, to be involved in solving challenges of climate change or earthquakes. So that's why I'm very interested in them.
The field of spatial structures is an exciting one, which has changed rapidly over the past half-century with the emergence of digital tools. But what will be the technologies and trends that will revolutionize the production and design of spatial structures in the future? Juan Gerardo Olivia Salinas, architect and professor within the University of Mexico's Faculty of Architecture, believes engineers will focus on exploring the possibilities of advanced digital tools and new materials.
I'm sure that the digital tools are the main tool to be used in the future. We have to think also of materials, maybe that we consider they are all materials, but if they are good, we can use them and we have to use it. We are working currently with materials like bamboos, like paperboard, like bricks, because it is also possible to use again these materials, applying the new technological methods we know. Those are the research projects we are working on, and I think that should be the key for the future.
Emeritus Professor Jerry Park sees the potential for lightweight foldable structures.
Well, I think the future of spatial structures is that architects and engineers are trying to always come up with new types of structures with the aim of achieving a structure which spans further and it's lighter. But of course, when it spans further and it's a lighter structure, you have all sorts of instability problems, which are quite complicated to analyse. A growth area, I think, is going to be going back to foldable structures, and where the structure can be folded up, it can be taken up into space, and it can be opened up in space, and we can design structures which will be suitable for putting on the moon. So they're built down here, they're folded down here, they're carried up there in a compact form, and then they're opened up. So there's a whole, all sorts of things that could go on, really.
Sigrid Adriansens thinks that while digital design and analysis tools have become widespread, there will be more interest in robotic fabrication techniques in the future, in order to enable innovative designs.
I think where a lot of work still needs to be done is leveraging the new fabrication techniques that are coming out. So we have embraced the kind of design and analysis methods, but I think the digital or even the robotic fabrication methods, I think it would be very interesting to look at what can these techniques do and how can we use them to inform our design of shell and spatial structures better. So I think that is very exciting. I think people have started doing that, but there is still a lot to be done, and I'm very curious to see what novel forms are going to come out, what novel uses for these systems are going to come out if we start really thinking about how they can be used, how they can be designed using these digital and robotic fabrication methods.
Of course, we are increasingly aware of the vital importance of creating designs that are not only functional, but also sustainable. René Motro believes this is what will drive lightweight structures in the future.
I think if I had to do something actually, I would be impressed by the actual situation of the world. So to say, to use materials who are compatible with the environmental challenges, and to use a way of working, way of building, which are compatible with that. And I believe that we can have lightweight and spatial structures which can be achieved with compatible materials. And we have to make a work on this. And my idea, this is like an utopia. My idea is that if we have a look to the nature, form of flowers are moving, and we can dream of a building mode with folding and unfolding building for some experience. We have some experience like this for some specific situation of disaster, where we can open some enclosure for like this.
Carlos Lazaro agrees that the need for sustainability will lead engineers and architects both to take a different approach when it comes to materials and to find new ways of manufacturing using advanced technology.
The exciting thing about the future of spatial structure is that it is driving the innovation in the field in order to achieve more sustainable and better structures with less environmental footprint. And I think this aspect is very important. It is also very important to think how some of the ideas that architects can develop without really thinking in how they work, structurally work, how these ideas can be, let's say, in a collaborative effort, adapted to be really efficient. And that means that the association, the people who are related to the association and to spatial structures and to all of the conferences that we are talking about, they are really doing a great job to drive the future of structures to how to build better and in a more sustainable way. I think that the development of new materials and new manufacturing techniques is two examples of how this development of spatial structures can develop in the future. It has been that way in the history of structures. So when a new material appeared, you need some time for engineers and architects to adapt it to new sorts of structures. And this is happening now. We are having new materials. We are reusing materials in existing structures, and we are we see how robots and new ways of manufacturing are revolutionizing technology, and we have to think how all this can be combined to the best for the society.
Olivier Bevrel, a professor at the École de Pontparytech and co-editor of the International Journal of Space Structures, outlines what he sees as the main challenges engineers and architects will face in creating environmentally friendly structures.
I think what is exciting about the future of spatial structure is that we're going to be one of the main actors of being able to do a sustainable society. You know, we're doing, our industry is creating 40% of the waste, and it's consuming a lot of energy. And our society, our spatial structures, has to act and find sustainable solutions. And this is a huge challenge. And this huge challenge will be possible to win only if we can find methods, tools to be able to work with within this complexity. I think the first thing to do to see the future of space structure is first for people to really learn what we speak about when we speak about life cycle analysis, and really understand how deeply we have to rethink our field and the act of building. And this is a huge effort to everybody to go one step up and to realize that what we're doing, designing, is at the end quite harmful to the environment. So that's, I think, the most important part is education first. And after, of course, is to start to develop tools and methods to help designers to be able to reach the goals.
Chris Williams agrees that while spatial structures tend to be lightweight, we need to look at the entire life cycle analysis, and most importantly, to consider the lifespan of the structure in order to truly understand whether they are sustainable.
Obviously, we're increasingly aware of sustainability and carbon footprint and stuff. That's where the argument gets quite difficult, because one of the problems that you find with spatial structures is that the structure itself is very light and doesn't use much material and energy, but then of course you've got all sorts of other stuff, the cladding, insulation and so on. And one of the problems that you find actually is that with very lightweight structures is that the cladding and the insulation end up being a larger part of the total structure than just the structure of the shell or the space frame. And then of course you've got all the foundations, you've got the heating of the building throughout its life, and so on. Well, I suppose for me, the most important thing is that if you make a building or a bridge or whatever it is, that it should be functional and that it should be used for a long time, ideally. Obviously, if you make something that's used for 500 years, then however much energy you use in making it, that is energy well spent. Whereas if you knock it down after 5 years, then however efficient it was, then you've obviously used a lot of resources and so on.
Meeting the need for more sustainable buildings and structures and exploiting the potential of new materials and techniques will require fresh ideas and fresh minds. A significant question is therefore, how can today's experts and the IASS itself go about inspiring the next generation of engineers and architects who will drive the spatial structures discipline in the future? Juan Gerardo Olivia Salinas believes that to invent the future, young engineers must first understand the past.
Yes, inspiring the next generation. That's the motto of the IASS 2020, and I think it's the right name. we, the old people, have the compromise to inspire the young generations. We have to tell them what we have done, how we have done it, and to tell them that everything has to be improved. We have not made the last word, only the beginning of many things, and the new generations have to produce new achievements. To do that, they have to know what we did, how we did, how the people who precede us did, and then they have to provide new solutions, new proposals of structures and ways of conceiving, designing, and building new space structures.
The annual IASS Symposium provides a vital opportunity for inspiring the next generation and creating a platform for them to collaborate. Carlos Lazaro, who chaired the 2019 IASS Symposium, talks about what the organisers try to achieve.
The motto of IASS 2020, Inspiring the Next Generation, is a great one, because one of the risks of our conferences, our societies, I mentioned the IASS previously, is that they get old. So people get old. So and even the most important people at some point are there, and they have inspired. They continue inspiring, but we need to open the door for the new generations, because they have the energy, the stamina, and they have the ideas. And this is something that in the Spatial Structures Conference and then in the IASS we have always tried to do. We are always thinking, how can we incorporate new people? And I think we are pretty much successful in doing that. We are seeing this in Barcelona this time. There are lots of young people, and the interplay between them, so the possibility to do networking, this is very important. So they need to meet, not only using digital tools like social media and so on, but in person also, and that's very valuable.
According to Harith Gantes, the young generation will be inspired both by the creativity of this discipline and its potential relevance to meeting people's basic needs.
I think structural engineering has been lucky as a discipline in general to attract very gifted people, and we must continue to do that. It's not obvious because it's becoming an old and mature field, and the younger generation, naturally they want to do modern, exciting stuff. So I think it's important to demonstrate the relevance to society. This is an important aspect. I think creativity is an inherent part of this profession, so this is a good argument for attracting gifted young people, and we must blend into this traditional field modern technologies to the biggest extent possible. This is related to the discussion we had before on digital technologies, and the importance for society is from one point of view related to the environmental impact that we also discussed. Another thing is that there are parts of the world where basic needs of housing are not covered at all. So we must address these problems, and I think that we will continue to make this an interesting field for the younger people.
Olivia Bevrel agrees that sustainability will be central to inspiring the next generation, and believes that 3 levers in particular will be extremely important.
So to inspire the next generation, I think, of course, around the question of sustainability, I think we have 3 levers, which is the first, the question of geometry, how to master the geometry and to provide solutions that are buildable without having too much optimization and post-rationalization to be done. Second is a question of materials and new materials, printable materials. And this, some advance, recent advances are really interesting. And the third one, of course, is the numerical tools to actually produce structural elements. And these are the three, I think, key parts. In the last part, there's certainly a lot of work to be done with artificial intelligence, with neural networks and all these things to be able to have more automation of the use of robots to build, to assemble things in a complex manners. And this is something that's going to be extremely interesting in the future.
This question of inspiring the next generation of engineers and architects naturally leads us to consider how the teaching offered by civil engineering departments within universities will need to evolve in order to stay relevant. At the University of Surrey, the DAD project is an important element of first-year civil engineering students' experience. In the project, they're challenged to design, assemble and dismantle a full-scale lattice structure within a 2-hour timeframe. Emeritus Professor Jerry Park from Surrey explains the importance of this kind of hands-on opportunity.
I think probably the most important thing is to talk to the young engineers, and before that school children and very young children. And the project that Dr. Ali Reza is using here, the DAD project, which is design, assemble and dismantle, is a very good approach. Also, I think last year the Institution of Structural Engineers had a competition for school children to design a space structure in space, so an actual space station, and they got an enormous number of entrances. Some of the structures that came up with were fascinating, really, really very, very interesting. All of those things get people excited, so I think that's probably the best way.
Carlos Lazaro highlights what he believes is one of the problems when it comes to educating the next generation.
Maybe one of the difficulties with education of spatial structures is that because the field is a mixed field between architecture and engineering, there is no clear space for it in a standard curriculum, the standard architectural curriculum or the standard engineering curriculum. And I think that in the future we need to find new spaces. It has been done already in some universities, so spaces to provide this mixed or combined knowledge to students, and using digital tools, using physical modeling, using devices. So we need to get the best from all fields in order to offer the young generations a good background in this field.
Sigrid Adriansens agrees that teaching needs to become more interdisciplinary, whilst also ensuring that students have a deep background knowledge of spatial structures.
For the education of spatial structures, I really see two ways that this needs to be done. On the first hand, I think that students need to have a very good, deep understanding of how these systems work. At the moment, there are a lot of digital tools out there that allow them to generate these systems and quickly do analysis. But I think the very deep background knowledge as in how these systems work, and if you see what you should be looking out for, that is totally gone. So I think in one way, I would say we need to go back to more traditional courses like shells and plates, so that our students are imbued with a sense of how these systems are supposed to be working, because that will then really inform when they are looking at the systems that they generate, whether they work or not. On the other hand, I think we should expand our thinking beyond just engineers and architects. There are a lot of people that are interested in the generation of these geometries, for example, for shell and spatial structures. And so these are mathematicians, architects, engineers, artists, product designers. And so I think courses that kind of bring all these people together, that have different backgrounds or different strengths, but I can actually work on these projects together, that is really going to be needed, I think, to drive these systems and their development.
While the future of spatial structures will unfold in unexpected ways, one timeless quality of this discipline is the unity between complex engineering structures or shapes and art. To conclude this podcast, we asked our experts to envisage how spatial structures will continue to be influenced by artistic and architectural trends. Carlos Lozaro believes that art is an important part of spatial structures and vice versa.
I think that the combination of art and spatial structures is a very significant one. We see when people look at a spatial structure, if it is very well designed, if it is the result of a master of construction, they will have the impression that they are observing a piece of art. So it's like looking at a sculpture sometimes, and this impression is there. So some structures have already this quality, and in other cases, artists are inspiring specialists in spatial structures to use their tools in order to improve or to make an artist's idea possible. We have seen that in the last IASS symposium in Boston with Janet Ekelman, with those kind of hanging nets that are only possible with use of digital tools and structural modeling. Very complex, by the way.
Professor Jerry Park tells a story from his experience as a tutor of structural engineering students, when the artistic element of the discipline was the spark for some much-needed inspiration.
And I'm a great supporter of art influencing spatial structures and spatial structures influencing art. I think both can develop a lot from it. Don't forget, structural engineering is a science and an art also, because there's a lot of decisions that you make which are not probably 100% scientific. I had a nice example a few years ago. I had a Greek lady on the MSc course in structural engineering, and she had to do a dissertation, and she came to see me. She said, I really don't like structural engineering. My dad told me I had to do this MSc course. So I said, well, what is it that you really like to do? So she said, well, I really wanted to be a fashion designer. So I said, okay, let's think about this. Why don't you design for me a large sculpture, which will go on campus, of a flamenco dancer? Okay, so you could do the outside and the costume and all that, and then that would have to be supported. So inside we would have a space structure, like Statue of Liberty in New York, which has a space structure inside to hold it up. So that's what we decided she would do, and she did a really, really good job on it. And she was excited by the whole thing.
Juan Gerardo Olivia Salinas reminds us that even the best artists don't work in isolation, and that it is collaboration, the bringing together of different disciplines, which delivers real innovation.
Working together. Nobody makes the things alone. Also, when we say this is a work from Gaudí, I'm sure there were many people on the side of Gaudí working. And if we work together from the starting on with the engineers, then we, as architects, then we have a better result. So it is a working together, a working and making teams to the sake of the structures, not for the sake of my name. Because it's wrong when I say, oh, this is my building, this is my project. No, this is my idea maybe, but the idea is developed with a group of people. And the group of people is the ones who deliver many interesting solutions. In some of my projects, I always try to involve students, and the students have always very fresh ideas, very new ideas, and I use them. So So the working in groups with different disciplines, I think, is a better way to have a better result.
In this spirit of collaboration, the IASS, led by many of the people we've heard from on this podcast, works tirelessly to offer events where engineers, architects, and others to explore ideas and work together. IASS 2020, taking place at Surrey in August 2020, promises to be an excellent opportunity for this. This brings us to the end of our podcast, so I hope that you've enjoyed this glimpse into the future of spatial structures and their synergy with the worlds of engineering, art, and architecture. If you'd like to learn more about the history of spatial structures, you can listen to our podcast, The History of Spatial Structures. Thanks to experts who've made such valuable and interesting contributions to these podcasts, and thank you for listening. My name is Mark Richardson from the University of Surrey, and we leave with the final word to Olivier Bavrel, who identifies the innate quality which makes spatial structures endlessly fascinating.
You see, my interest in space structure is also the question of beauty, and each time I see beautiful structure, I understand why I do this job, and I feel that it is part of the job also of engineers to contribute to make something nice. And if you look at a beautiful structure, there's rarely vandalism on it. They are respected. If you work well, you do nice things for people, people respect it.